All right, welcome everybody. This is the official anniversary stream for Chiller Academy, and I couldn't be more excited. HVAC Time as a brand, we're a solid 7 years into this now, going on 8, I guess. So it'd be what 7.5 years since because I started in October, and then yeah, just with the way life has gone, and there was a lot that led up to, making the decision to go forward with Chiller Academy. And I'm going to share some of the numbers. I'm actually, for the first time this morning, actually sat down, ran the numbers, and actually got proper totals on where we stand after this first year. So I'm really excited to share those here momentarily. But, it's just been just a crazy journey. And I've really been trying to figure out for years, what is a way that we can really start helping our industry move forward and improve and fill this gap. So we all know that there's a severe manpower shortage. We just do not have enough of us, not enough technicians, nothing at all, right? It's not that there's none of us out there, obviously, but there's not enough of us. And while there are a lot of we've had progress, like I've been working on this mission of trying to help the industry prepare the next generation of technicians for many years. This has been on my heart for a long time. But there's, even though we're just getting started in, we're starting to get more people coming in. That's what I'm trying to say. We have had success. There are more people coming into the trades, and our culture is realizing that there are more legitimate paths for your life than strictly going and getting a college degree of some kind. Even though, I mean, technically, I went through a trades program. I was able to get my actual degree and associates through that program, right? So I'm college educated as far as that's concerned. But what I mean specifically is actually coming through a trades program, getting trained, versus going through getting a bachelor's or something in who knows what. I mean, how many messages I get routinely from these people who went into the tech sector, and they're in big trouble right now. And there's a lot of people who are trying to find ways of just completely getting into a trade of some kind and getting out of what they're doing because that whole industry just kind of fell apart under their feet. And they're wanting to do something that they feel they can bring more value to, I guess, our economy is how I would say that. Anyway, my point in this is I we needed a way to help everybody who's getting started to more quickly get up to speed because we're already in a space. I talk to business owners weekly, and we are already in a space where there is way too little there's too little of experienced people. We can get apprentices at this point. Like that whole part of the cycle has began to happen. We can get apprentices in, and we can start to train these entry level positions, but there's no experienced positions. And that really leaves us in a spot where if we follow the traditional roadmaps that the industry has built, and we as an industry have handed the responsibility of training and education to the institutions and to the manufacturers. I mean, by my estimations, 90% of the education we have in our industry happens in one of those two places, either through some kind of institutionalized trade school or you go through a manufacturer training of some level. The issue I see is with the way that we've done this and we've structured that and how they have continued to operate, it's not supporting our industry's needs anymore. Like they're not keeping up with it. In addition to that, um, most of the time while you're in trade school, you don't actually get to be in the field with your instructor or have your instructor's material directly there with you. And a lot of the instructors we have very little field experience themselves, so they can do a good job regurgitating what they've read in their own material, but actually being able to explain to you how to apply that. And that's just on basic, HVAC type stuff. We're not even talking chiller side like what we're doing. And then even on the chiller side, we have this concept that somehow you're supposed to go to a class in person, or even if it is online, right? COVID, one of the things it did is it forced some of these manufacturers to start offering more robust online versions of their stuff, right? And so you can go do some of those, but they're still 2 or 3 days, right? Or they're 1 week into stuff. And I'm not trying to harp on them, but I am calling out where our industry is and the problem that I see and I saw that led me to walking down the path of Chiller Academy. So somehow you're supposed to go sit in a classroom for a few days. You get to take notes. You get handed some portion of documents, right? You get some manuals of some kind, even though some of them may not be that helpful. And then you go and you just go do. Like you've got your notes as if this is a realistic method of learning something, where you go sit in a classroom, you take a bunch of notes, and then you just get slung out there. We don't have the senior technicians in the field anymore to help guide us. Our service managers are way too spread thin to realistically be able to help us navigate as technicians, as apprentices, and as junior technicians trying to come up and get our journey status. That there's just not enough support for that right now, and there hadn't been for quite some time. And so in the days when we still had a large core structure of experienced senior and experienced journeymen where you could send an apprentice to some of these classes. They spend a few days, they get a lot of really good questions answered, stuff like that. Then they come back and they get to then continue that process in the field with their journeyman they're working under. I think that worked fine. I think that was a system and a process that had merit. But we don't have that. We haven't had that for quite some time. I mean, the retirement phase started at least 10 years ago, and it hit a critical mass about 5 years ago. And over the last 5 years, we're on life support in terms of our experienced senior support inside of this industry. And that's okay. Okay, all right? I want you to understand that. This is amazing for those of us of this generation and the generation coming in behind us who are going to fill these roles, because the opportunities that are at our feet are absurd. The generations that have gone before us would have given a lot. They did sacrifice a lot in their life because there was such an abundance of people. Companies had choice. Today, companies don't have choice with who they hire, really. We have a lot of, call it leverage, to get in with a company we want and get the type of job we want in ways that historically wasn't true. So this is our opportunity to really step into this industry and shine in our own way and just love what we do. Like genuinely get into this, have fun, and love what we do. I mean, it's hard, okay? It's hard physical work and labor, but it's extremely engaging. It's extremely rewarding if this is what you want. So this is the opportunity that we have today in the face of the fact that we've lost so much of that senior support, and the people that we've historically given responsibility to training and educating have not adapted, in my opinion, adequately to the forms of education that our industry needs now. And that's where Chiller Academy was born. right? And that was the whole concept and the thought process behind it. And it was a very community driven aspect. That whole, for months leading up to uh, starting Chiller Academy, and conceptualizing it and starting to build it, we were having a lot of discussions here on YouTube about, and this is through community polls. Like, I can't tell you how valuable these polls and stuff are in helping me make decisions that are best for what you need in your time. So, like, it was those polls that helped me understand where do I fit in this, and how can I really do something that's going to make a difference and actually step us forward with the technologies we have today, so that it's just more available. Like, it's one of the struggles we have is the education and the training and the direct support. It's just there's a lack of availability on most of those levels. And so once the concept of Chiller Academy came to me, things just took off, and it went straight into, this is it. Like, this is the move. I turned in my notice with the company I was with at the time, and just this whole process really just took off. And yeah, like, I threw everything I had into it, and it's been incredible, right? The fact that we have a resource today, like, this is genuinely the thing that I dreamed of having as a young technician, having access to the information first of all, but then it being done in a way to where you really get a lot of support. Like, having something to where I can take my instructor into the field with me, because that is really part of the concept. Is I wanted to make this in a way to where I can go with you in the field, and I can teach you the material while you're in front of your machine. Not a machine, not my curated test machine, your machine. That's what that was one of the big concepts that I wanted to accomplish, is how do I get there with you on site? And I think we did that. I really do. I've got a lot of ideas on how to improve this system and how to continue making things far more friendly and usable and accessible. Like, I'm full of ideas, and it's all going to take time. Right? I don't have a big team or anything else here that I'm trying to do this with, and there's lots of reasons for that. But with time, we will continue to make something better and better and better and better, because I can't communicate in my gratefulness how appreciative I am of this process, because this is genuinely the retirement plan I set out to have when I decided to commit to this industry. Because I didn't I didn't choose to make a career of this industry and early on. Well, this wasn't intentional, this industry for me. I fell into it. It was just a young kid trying to just make a living at the time. I had a lot of skills coming up in a trades family. Just kind of, I walked into the right opportunity. And that opportunity opened a career path to me that I never even dreamed of. And got married, and we knew then my dream was to retire from the field, originally at 40. That's what I wanted to do, retire from the field, because I never actually planned to legit retire and go on cruises and do like whatever that stuff is. That was never actually a idea for me. What I wanted to do is go into education, retire at 40 from the field, go into education full time. And things I learned along the way, having actually worked at some of these institutions and taught classes professionally, and through this whole journey, I learned quite a few things. One, me waiting till I was 40 was only going to make the industry suffer more as a whole. Like everything was only going to suffer more because I didn't see the people. We haven't taken the steps we needed to as an industry, and I didn't see anybody doing it. At some point, somebody's just got to step up and do it. That's the way I see it. That ultimately just kind of fell on my heart to do. And so, yeah, wait until 40 wasn't going to help anybody at all, including myself. Then we have the technology and the systems to do this now. And yeah, I mean, I learned that working inside of the institution environment, I didn't fit in their mold. Like the team I worked with are absolutely incredible. I love the people, but the structure and the mold and how these programs are expected to function, I knew that if I committed my retirement to that, to me it would feel wasted in the long run, because I knew that for what I see as our landscape as an industry, I only contributed to the problem, not fixed it. That was an issue for me, a big issue. So this allowing me to retire at 30 from the field, right? And be able to build this, and I have time and life and energy to really do something that I feel like will make a difference. Yeah. This is my retirement, and I appreciate this process, and really look forward to the decades to come that will be what we make here. And this is a community effort that we've all put in together, because there's been so much of this that has come from y'all's support and being able to make this possible. With that, I will conclude this whole section with where we are in terms of our numbers. I'm very excited about this, because to be able to do this in just 1 year, I mean, it's crazy. So in terms of technicians, there are 2,300 technicians in the academy in the first year. So 2,300 of you as a total have come in and engaged yourself, and we've been working together. Like, it's just, that number just, it's crazy, right? Just, I don't know what to say, really. It's nuts. And then lesson completions. So these are, by lesson completions, that metric is how many lessons are have been marked as completed. So, inside of each course has a section of modules, and those modules have lessons inside of them, and it's all organized and broke out accordingly. And so each of those lessons that were marked as complete and you feel were finished on your end, this over 25,000 lesson completions in the first year. So that's a lot. That is a lot. Yeah, I just thank you. Thank you for this journey and this process, for all the years. A lot of you, I see you guys in the chat. Y'all have been around a long time for what we've been working on and doing here. I've gotten to meet many of you in person, and it's been awesome. So I don't know what else to say other than thank you. I appreciate this first year, and I've said this many times in many ways, but this is only the beginning. We've got so many ideas, so many thoughts on where to go, what to do with this, and how to really make something that steps our industry forward. Like, that's what we've all committed to this for. We have a problem. We have a way of helping us with that problem. May not be the solution, but it is a way. And together, we'll make it what it needs to be. So thank you. Okay. Catch up on the chat here. Ronald from Qatar. Oh, thank you, Ronald. Yeah, there's actually, that's been one of the things. I didn't expect the global side of this whole thing to scale to what it is. We've got Qatar. I can't. There's so many countries. I can't even keep up with them all from every continent. Like, I know for a fact we've got people involved in this from every continent, and like, that just blows my mind. But thank you, Ronald. How to function? Okay, I'll get to questions here in just a second. I do have a few questions that come from the Academy. So I've got a portal now for these live streams through chilleracademy.com. So you can go join that portal for free. You can see all of the past streams, and I also break out the various questions into their own separate segments. And I post the upcoming stream so that if you have questions you want included in that stream, I prioritize those questions first, and we'll cover those, and then I start rolling through the additional questions either in the chat, or I've also got a repository. So if you do end up having a question while you're watching a video, feel free to go ahead and post that question, and I'm actually saving those now into a question bank, so that when we're doing these streams and such, I can pull from those and try to answer as many of those as I can. Yeah, how's the market for chiller mechanics in Austin? In dire need. Just short, simple, dire need. There are several companies locally who I speak to on a regular, and they're begging for proper support and help. These are good people, most of them, and yeah, dire is but I think that really sums it up. See, Jason says the market is dying. Oh yeah, okay, I get what you mean, Jason. With the way you said that the market is dying, I thought you meant like dying as in going away, and I was quite confused. No, you mean dying as in what I said, dire. It needs it. So, anybody know any good books to go over rigging fundamentals, more specifically geared towards chiller rebuilds? Overhaul manuals on that, Ray. So I'm just kind of skimming through these. We'll get to the main questions here in just a moment. But Ray, overhaul manuals tend to discuss the rigging requirements decent enough. And we can discuss that separate from here if you want to send me an email. Yeah, thank you, Jason. Yeah, I see you, Froggy and Jason. I appreciate you guys. Y'all been around a long time. It's a manufacturer. Oh yeah, by the way, I do want to circle back on this with Jason. So Jason, if y'all don't know, he has his own channel, and he's been posting his own like field videos and stuff. The stuff that I did early on, right? He's doing a lot of that type of stuff. So if you're really wanting to see more of that field content, and maybe you're bored with, or you've used up whatever I have in the archive of YouTube, if you will, feel free to go follow Jason and check out some of his stuff. He's got a really good flow going, and he's seeing some pretty cool stuff, right? I would just really encourage you to go look at it. You can see a lot of field related content, and actually him out there doing the work. Whereas, I've transitioned in my role. So really encourage you, go check out Jason and see what he's up to. As a manufacturer, I appreciate having you and getting awesome knowledge from directly from the field. Jim, sir, thank you for you. Yes, thank you. Penguins from Antarctica. Okay. All right. So I guess I forget about Antarctica. We might not have anybody in Antarctica. I'll give you that. Fair enough. Oops. Just recently I was sent to a chlorine plant where 10 managers and workers hovered over my shoulder while I worked. Oh yeah, no, it is. It is. When you get as part, especially when you're fresh as a tech, this is why I started with the certification course. It was intro course, which is rebranded. That was a community decision. But that's why I started with that. See, I could teach you how to do the service work and how to do step-by-step repairs. And I have that. I have the service training program, and that is getting built out. But reality is, if you don't know how to articulate and clearly communicate what the systems are, how they function, what they do, I can't tell you how many customers, they have no idea themselves what the correct answer is, but they will ask some of these questions and they will watch how you're working, because it communicates to them via how you react to different scenarios, your body language. They want to see confidence and that you have a grasp of what it is that's in front of you. And without having that, not only with the customer, but also when you are trying to fulfill a service procedure, if you don't properly understand a specific aspect of something, of a component, or how something is meant to work, what it's designed to do, then doing the actual work, one, you're probably not going to do it at the same quality, because you're going to, like, everything becomes a second guessing game. And you don't really know what the baseline is for correct. You don't know what the like the foundation is of what it's supposed to be versus what it's doing. So if you don't have that, and that's where you get into the situation with the customers, like that's going to be a routine thing, especially when you start getting into these big plants. And a lot of these manufacturing facilities, if you don't keep things in a tight profile on how the system's supposed to operate, like these are actual explosion potentials. Like these are things to where things go wrong. Not only does it cost them millions of dollars of downtime, but you could genuinely cause a site evacuation, which then takes that millions of just the line being down and production being stopped, to now we've got all of these safety regulatory bodies having to flood in and all this report. Like, you just made their life ever loving hell. I don't say that as a means of trying to add more pressure, but I say that to try to communicate the seriousness that we need to have in really understanding our machine. You don't have to have all the service experience in the world. You'd be shocked at how much easier this becomes. I mean, utterly shocked, when you actually understand this system, the components, and you have a baseline for what's supposed to happen. When you can walk up to the machine, identify a couple of parts, understand that, okay, these parts do this, so when you put these together in this way, I should expect this. Right? When you can do that, it doesn't matter if you truly know that machine ins and outs or not. You can make so much more progress and you can do so much more to help that customer just because you have the foundation. I cannot stress that enough. And it's so easy, because I'm the same way. You get caught up in wanting to know how to do something, that it's so easy to just kind of breeze over the fundamentals of what these things are until you get to the point where now you've got to make a decision. Is that valve right there part of my problem, or is it helping me? Like, do I need to troubleshoot that valve right now? Well, if you understand the core functions of what that valve is meant to do and why it's there, you may realize it has nothing to do with what you're dealing with, and you need to move on to something that does. But without that foundation, you get hung up right there, and you could spend a long time trying to understand what that valve is doing and trying to troubleshoot it. And if it's a part of your process and hurting you, just to realize it was a waste of time. Now, like, yeah, I could rant about that a lot, and I rant about it because I am that way. I am my own example there when I talk about something like that. So, um, really, really encourage you get the foundations down, and then like whenever you have to then present things to that customer or they're hovering over your shoulder, and especially if they start asking questions, you can give confident, educated answers because you don't have to know that machine, but you know what that component is and what that component is meant to do and how the whole machine is now functioning. Because that makes a huge difference in your ability to confidently assess a machine. Anyway, I will get off my soapbox. Okay. Welcome everybody. Enjoying the chat. I just finished a lengthy enough spiel over our first year with the Academy. Very excited about this. I am going to roll into some of our questions and we'll get things going here. I appreciate all of your time. The first one up on the docs comes from our portal. So, I want TT SMT 2.6 to onward version for Turbocor, and I've 2014 Turbocor not powering up, not showing anything. What could be cause? All right, I do want to preface here, okay? This is a translation issue. I appreciate the global market, okay? I don't be intimidated or anything. If this is the best your translator can do, it's fine. I'll make it do. So I just don't let translation issues get in your way, please. I've got enough information here. We can make an assessment. So with this, so you've got a Turbocor. You're having trouble with it not powering up, and you're also trying to get access to the SMT, the service monitoring tool by Danfoss. So that tool is free through Danfoss's website. Now, if you are overseas, I have seen some weird issues where you can't, because when you connect to the internet, it pulls your IP, the service gets a general sense of your region that you're in, and if it detects that you're in a, call it unsupported region, you may not have access to some of the web pages that you can download these things through. If that is true, the only option I know personally to do is to some of those VPN type services, which I don't even know if that's available globally. I really don't. I'm not educated on this stuff, but if you can get something like that where you register as in the US or or just somewhere else, you may be able to have access. So I could tell you, hey, go to, like, you could just search SMT or Turbocor SMT download, right? Something like that. And if you're in the right region, you should have a option on a web page pull up to download the most recent version of SMT. And it is free. It's a free software that you can download. Now, if you're in a region that's not supported by Danfoss, you may not have that page pop up as an option to you. And I've had situations where my internet, for some reason, had me show up in a, and actually, specifically, I had one time where my browser kept reporting that I was in South America for some reason. And I was actually, it may have been, I think it was actually Danfoss at the time. I was trying to pull up what version of SMT we were on to see if I needed to update it. I don't know why it had me pulling up there because I was in North America. Either way, it wouldn't present the page to me, and that's how I even know that this is a problem. Was that experience. So, yeah, if you're in a non-supported, you'll have to do something. VPN be the only real option I know of to try to get that software. And actually, that does give me an idea. One thing I may try to do is I could probably take the download package and post it in the Academy somewhere. this is something I can work on at some point. I gotta, either way, I can take the most recent version that they have, download the packages, load that into a file on the Academy where you can just download it. That way, even if you are in a non-supported country where it won't give you the web page to download the software, you can at least go to the Academy. You can download it there. So at that point, like, I don't have any restrictions like that on my side. My site should be fully open globally, so you'll be able to get access to that download. That may be something we try to do. Either way, that would be the way to get SMT, is getting a Google search like that should pull up that page to where you can just download the serviced software. Or you may try to put in Turbocor Service Monitoring Tool. If SMT abbreviated doesn't do it, type in the actual full name. That'll get you the software. Now, you also mentioned that the Turbocor is not powering up. It's not showing anything. So that means a couple of things to me. First, come on. There we go. First, so this is the top of a TT, should be a 350 series if memory serves. So depending on your particular one, you could see a couple of different things up here. One, the smaller ones don't have a fuse block assembly here. The larger ones do. So if you're not seeing anything boot up, and specifically what that could mean is either on your backplane board or your I/O board, which I don't have a quick picture of, but that's going to be down in the control panel close to the system controls. If those aren't having any of these LEDs light up or anything, then that would be an indication that the whole system is not booting potentially. So the first thing I'd want to verify is my fuses here, and potentially down inside the control panel. So there will be you'll still have a power panel with typically like a disconnect switch or a breaker in the power panel for the whole chiller as a whole, and then it'll pass up here through this port to the Turbocor terminals, and then the larger ones will have a set of fuses here. So whether it be, are you getting power into the compressor for the feeding the fuses, and obviously this one doesn't, or do you have a blown fuse somewhere, right? Any of those things are going to cause a scenario where it may not be powering up. So let's just first chase down, okay, we verified our fuses are good and we have power up here to the fuses. Okay, so next what has to happen is we feed through this terminal assembly and into our SCR bank. So these SCRs are then going to convert that AC power to our DC bus, which is right in here. So this DC bus feeds our capacitor bank on the backside, our inverter here, this is our soft start module on top of the inverter, and then it also feeds our DC to DC converter. So what powers our backplane board, which is this, so this whole assembly here is our backplane. What powers that is the DC to DC converter. So we're taking 600 volts DC off of our DC bus here and feeding into our DC to DC converter. So you have a couple of options here. One option, you may have a SCR issue. Another option, you may have a DC to DC converter issue. Either of these could be preventing you from feeding power, because if we have an SCR not working, then it's not going to feed the DC bus appropriately to boot our converter. And so if our converter is not able to process power, then it's not gonna work, obviously. Now, typically in my experience with an SCR, when it fails will usually short, like internally. And that's going to cause blown fuses issues. You're going to have main power issues when you lose an SCR, typically. But that is not the only way they can fail. Sometimes they can fail where they're just essentially open, and they're just not passing anything through. So that, more than likely, though, when I've had a situation like this, it's actually not a SCR issue. When I have power into the compressor, but I don't have anything on the backplane, Typically, that is not an SCR issue in my experience. It's usually something to do with the DC to DC converter itself. I've had these blow up many times. I can't tell you how many times I've opened up this top side panel and this thing has full on grenaded inside of there. Now this is a little bit of a newer version. They had a different version in the past. Either way, you will want to, I would, if I had power here and I didn't see any burnt wires, anything out of the normal over on the SCR side, I would probably come over here and first evaluate my DC to DC converter. This would be the first thing I'd want to do. And there's a test procedure for that. Now, you don't want to do any of this with live power up here. Okay, that is a big caveat with working with these Turbocors. Do not work on them, please, with all this powered up. That is not safe. So they do have harnesses, a test harness that you can get that will plug into various points, and it will you'll feed the harness down into the backplane area, and then you can actually test with your meter where you have various voltage points. So if you don't have power here, because this backplane board also has plenty of test points, right? That's where all these little pins here are. So if this is lighting up and doing something, you can start with testing here. But if you don't, then if you have that power test kit, or you can plug it in up here, run it down, boot the compressor, and see where you do and don't have voltage while it's live. Now, if you don't have that option, then there are test procedures to measure across this DC to DC converter and try to see if it shows any issues in testing between the pins and the input side, and what kind of what was it? These should be, some of them are resistance checks if memory serves, some of them are diode checks. So you'll have to go through that procedure, and there is a app for this. So you have the Turbo Tool app. A lot of these processes are in the Turbo Tool app itself. And so you can, if you don't have the manuals, then you can go to the Turbo Tool and pull up the procedure for this in there. Now, what I have found in the past is that if you have the actual service manuals for this, those do go deeper than I've seen the Turbo Tool app offer. Now, that may have changed with time. It's been a little while since I've used that, but that's just been one of my experiences. If usually the Turbo Tool app is easier for me to just pull up and access and try to run through, and if I hit a wall where it's not, something just isn't lining up for me on the app, then I will actually go to the books, take the time, pull up the manual, and go through the service check procedure for this. Either way, there's ways of checking this. So in your particular case here with the question on you're not seeing anything power up, it's either a input power issue, and this is saying that we have power up here and we didn't have a fuse blown, or it's going to be a DC to DC converter issue. Those are the two most common things I have seen. Now, beyond that, like, we could spend quite a while here trying to work through every possible variable with these turbo cores, but that would be the 2 points I would want to start with and verify. Now, if you do have a blown fuse here, or if your breaker or disconnect did trip on the main input power side, then you need to take a lot of care and carefully analyze these SCRs, the capacitors, and potentially, probably not the inverter. If there's an issue, it's probably going to be in the SCRs or maybe a capacitor. But you really want to pay very close attention to the SCRs. And don't just replace the fuses. Don't just reset the breaker and turn it back on, please. If you do have a trip like that, go through these SCRs. Make sure that they are good, because if you may have gotten fortunate and it tripping off once just protected the machine from actually complete self-destruction. But I've seen it to where instead of taking the time to test anything, they'll just go in and reset the breaker, or they'll just throw a new set of fuses in and let it rip. And that shorted SCR then blows up half the system because it just the fuses and everything did their job the first time and protected the rest of it, but the second time you weren't so fortunate, right? So that's why I say, like, if you have a main power failure like that, and this is true on any drive assembly, okay, this isn't just a Turbocor thing. When this happens, verify your SCRs before you replace fuses and reset anything. Make sure that this part of the system is okay, because if it is not, and you haven't already done major damage, you will cause major damage, and that repair becomes way more difficult and more expensive to accomplish because you didn't take the proper time to work through the components first. Like, these things, like brownouts and stuff, happen, but it's not worth the risk of missing an obvious SCR failure by you just assuming. So please do not do that. So yeah, that would be the two directions I would want to go in terms of it's not powering on, it's not showing anything, my backplane board doesn't have any lights. So if this is true, even if you have the SMT software, you're not going to be able to plug in and interface with anything. Nothing's going to work. So you're going to have to get this side of the system online if you want to communicate with these modules and talk to this compressor and pull any kind of data, anything like that. Okay. So that would be my recommendation on how I would proceed, not only with getting the software, but also it not powering up. That's the two paths I've typically had to follow in that circumstance. All right. Excellent question. Now let's pull up the next one. We've got another one from... This is an interesting question too. I really like this one. Give me a second. I'm going to get it booted up here. What would be some indication of oil-logged condenser? Would oil pressure level / differential be low? So a oil-logged condenser. Well, we can take this from two different approaches. Let's start with a air-cooled approach, and then we'll go into a water-cooled, because that does a lot of the core basics of what I'm about to say stays the same, but it does change the format ever so slightly. The first thing to understand is majority of the time our oil is going to log in the evaporator itself specifically, and there's a few reasons for that. One, the oil is getting, like, it's being carried through the discharge line. So it's going to get carried into the condenser via discharge, which is at the top of the heat exchanger. And then it's going to be able to gravity drain its way down the heat exchanger into the liquid line, and then be able to flow into the evaporator from there. Whereas with the evaporator, typically, we're either injecting the refrigerant in from the bottom and we're pulling gas off the top, or even if we have a falling film, we're injecting it into a spray rail, which then the refrigerant falls to the bottom, including the oil, and we're still pulling gas off of the top. So either way, the evaporator becomes a natural trap for our oil that the condenser naturally isn't, because at least in the condenser we have the ability to gravity drain our refrigerant out. Now this is true for flooded and falling film. If we have a DX evaporator or a braze plate, it's typically not so severe because we usually have a much higher velocity through the heat exchanger. So with falling film and flooded, we don't have a lot of focused velocity that can carry that oil up the heat exchanger with the vapor and out. But with a DX, which the refrigerant is inside the tubes at that point, or with a braze plate, we can maintain a lot more velocity and a lot higher focused velocity. So what that allows us to do is whatever oil makes it to the evaporator, it has the ability to actually get carried back in a way that it can't with the other style, which is why, like with a DX or a braze plate evaporators, you don't see oil recovery systems with that. You don't see adductors. You don't see gas pumps. You don't see those things with that style of evaporator, because we can, as long as we can maintain velocity, we can maintain oil return. But that is not true with the other styles. Hence, a recovery system is needed. So the evaporator is going to be the place that you primarily collect oil. Heavy oil leads to excessive or high, call it high, approach values. And you'll also, which in the nature of being a high approach value, you're going to have lower saturations on the evaporator specifically, right? So this is all collecting there. Now, how that relates to in the condenser. There are circumstances where I've had condensers begin to struggle with oil logging. Usually I've found that it's when there's a high oil charge, there's just too much oil in the system, or we're not maintaining a high enough head pressure to maintain velocity through the condenser side of it. This is true for air-cooled and water-cooled, but especially on the air-cooled side most of all. What I've seen with air-cooled is because if the system is not perfectly level, then what I've seen happen is whatever side it's tilted towards, the oil will naturally kind of collect on that side of it. And especially in, say, a low ambient condition or something of that nature, when our condenser coils are cold and our condenser saturation is very low, if we don't get that condenser saturation up and we have a lower saturation, which is going to inevitably reduce how much velocity we have through that heat exchanger, we're not going to be able to push those little pockets of oil that stack up in the condenser properly. What that will eventually do is, if that were to happen, that will lead to a higher head pressures. Now, that is kind of a self-correcting effect, though, on an air-cooled machine, because if we're struggling, if the reason we're struggling with velocity in the first place is because of cold condensers, then less heat exchange is going to heat up our condensers, and it's going to kind of push its way through, and eventually it may hit this tipping point. What it will do, though, is it'll be far less efficient. Okay? Now, there are scenarios where if you have a really unloaded machine, so that compressors are heavily unloaded, that can lower the velocity through the system enough to cause a similar problem. But most of the time I find it's actually due to the saturation and the pressure and just the force of the flow going through there, which the pressures have a huge part to play in that. So that would be the air-cooled side. And on the water-cooled side, again, if we have excessive oil charge in the system, then I see it gets mixed in with the discharge a lot heavier. The oil separators will struggle if it hasn't. You know, this can happen with centrifugals as well, but be probably more of a water-cooled screw issue. Either way, the oil separators can't process enough of that oil out. A heavy oil latent discharge gas gets sent out into the condenser, and that can create a much heavier coating of oil on the condenser tubes as it's draining down. So that is a real scenario to where you may not be stacking oil in the condenser, but because you have so much oil making it into the condenser, it's causing a much heavier coating than would normally be created. So that heavy coating is going to elevate your head pressures, and getting hotter is going to be, in that circumstance, going to be minimal in its ability to self-correct in the same way that I talked about with an air-cooled coil. A water-cooled coil may not self-correct in the same way by those elevated pressures. So the best solution there is you'll just want to correct your oil charge in the system to begin with. And what is it? So what it's I have not seen it affect directly, the oil pressure or differential. Like those aren't going to be low in terms of something like that. If anything, they might start running high. But what it will do is it's going to affect your heat exchange and your saturation temperatures on both your evap and your condenser. Because if you've got a heavy enough oil charge that you're coating the condenser that severely to cause head pressure to elevate because of oil specifically, not because of other factors, then that also means that you're also heavily stacking oil in your evaporator, and that's going to be causing your evaporator to also run very poorly. So in my experience, I will usually see the symptoms in the evaporator first, and eventually, again, if it's bad enough, you will start to see those same symptoms on the condenser side. And my experience, it's high oil charge. There's too much oil in the system, and it's allowing that oil to get congregated and collected in mass in the wrong places in the system, more than the system was designed to overcome naturally on its own, which is going to affect your heat exchange. That's going to be the primary issue that I personally have ran into, and what I would expect to see in the field. Very good question. All right, before we take another, let's just kind of breeze through our chat real quick. Just say hi to everybody. How you doing? Welcome to the anniversary stream. It has been 1 full year with Chiller Academy. I was saying earlier, I did a whole spill if you want to go back and watch the beginning of the stream. But we're at 2,300 technicians in the first year. And for lessons completed, over 25,000 lessons have been completed in the academy, which is just, those are just, for me, like, those are crazy numbers, especially being year one, right? Those aren't year 5 numbers. Those are year 1 numbers, which what do I do with that? Like, it's just, anyway. Thank you for joining the stream. Welcome. Where can I get training on YK? Johnson, South Africa. Traveling is not a problem, but if training requires be in person. Oh, yeah. Richard York has started doing some online training. I don't know, though, that they offer it internationally. I think it may be just US based, so you may not be able to get involved in that. Yeah, so at that point, in person, in terms of in person, if you could get York factory to allow you to come to the States and do some stuff there, but they do, in my experience, I have found that they do have some regulation on who they allow in their classes. They don't openly talk about that, but I've talked to enough people that there are people that get turned away even though they have space available. So yeah, you'll just have to discuss. Actually, York does have a administrator that like coordinates and takes phone calls. Like, so you can actually reach out to York. It says Johnson Controls Training Institute, if memory serves, or something to that effect. You can get in touch with their administrative team there, which last time it was a lady that's kind of heading all that up. As far as I know, I don't think it's a whole team. Every time I've reached out, it's been the same person I've ended up talking to. So I'm assuming it's just the same person. Anyway, they can help navigate those questions and how you can get involved. Just knowing, knowing the fundamentals will make a huge. I mean, it's so much. It's so, like, hindsight, looking back. It's obvious to me. The stronger my foundation became with the fundamentals, the easier my troubleshooting and everything else became. It makes such a big difference. Yes. Customer education helps a lot with system abuse. That's a good way to put it. Reduce abuse on the machines. Yeah, I like that because I mean it's true. They're the ones making the decisions on a daily basis and stuff. Are there any courses on chiller commissioning, specifically alarm functionality testing to ensure equipment is meeting design? So some of the manufacturers will take you through just in their general like model specific certifications. They will talk about, you know, some of those commissioning and startup parameters that you'll need so that you can, like, part of their certification is you're startup certified is part of what they're suggesting. So you'll see some of that if you want to get model specific. In terms of general, that is where, you know, my personal certification course, it would be one I could recommend there, because a lot of the information you need to do a successful commissioning and like the going back to the foundations of things is in that course. And then if you have questions beyond that and you're actually out there trying to do a commissioning and some of these things aren't making sense to you, well, then you have support where you can reach out via in the comments or in the community page in there, and we can help fill in any gaps and help connect those dots for you so you can work through it better. BitTorrent and services alike. Don't trust. I don't know. What's the difference between CVHE and CVHG? Size. So the G is it's a larger tonnage system, where let's see, CVH. Let's see, they have CVH E and F on, I forget what the split is on the tonnages. It's like 1,500, 2,000 tons, somewhere in there. I think E's get replaced by G's somewhere in that process. So you'll still have a CVHF in the larger tonnages, but the CVHG replaces the E somewhere in the. I'm pretty sure I've got that right in my head. Working on an account, 2 Daikin. Yeah, awesome. How you doing, Sterling? I see you there, buddy. Over here, companies make it hard for techs to get into turbocores and even harder to get into centrifugals. Now I fully understand there should be some barrier to entry. Yeah, I mean that's a should there be a barrier to entry? To a degree. I think we need to be careful though, and I think, I don't know, Sterling, you being in Europe, do y'all still struggle with the same technician shortages that we face? Because I know y'all have got a bit of a different culture, and y'all have also kind of been through this cultural iteration cycle maybe a bit sooner in that process. I'm really not sure. Y'all have just got to, I've learned through speaking with guys like yourself, y'all have got a different way of operating and seeing things in your regulatory bodies. So do y'all have the same level of like manpower shortages? Because one of the big things that we have right now is, because we have such a severe shortage, a lot of the traditional rules about getting into centrifugals kind of gets pushed to the side because, well, somebody's just got to work on it. We don't have anybody available. You may not properly know how, but you're what we got. Go do it, right? That's what it eventually turns into for us, or in the U.S. So, yeah, I'm curious to what your experience with that is. Let's see, 400. That's an older model. We just stopped putting. They act like you should have a PhD from Stanford to even learn it. Yeah. Let's see, my question. What's your advice to a tech who's comfortable working on screws and desperately wants to get into? Ooh, this would be a good question. Let me circle back around to that, Sterling. So I've got one more question in the queue. Let me jump on that one from the Academy portal. And then, Sterling, I'm going to circle back around to your question, sir. All right. I will pull up a picture for this one. We can do some more show and tell. Okay. Let me get the picture pulled up here. Just give me just a moment. Let's It's thinking, it's thinking, it's thinking. There we go. Okay. So, typically, where is oil return solenoid located for a YK? Would it be on the eductor? Yes. So it is actually in the back of the eductor. So this is where the size of the machine does have an impact. So this would be a little bit of a smaller one. Some of the larger ones have a bit of a different design, where the tank is down, or the sump is down on the bottom underneath the condenser, and the piping and stuff for the eductor assembly all runs down there, and that changes the exact location of the solenoid itself along with the filter and whatnot. But in a general parameter, this line right here is the hot gas line coming off of the top of the condenser feeding into the eductor assembly. So there is a eductor block inside of here. Again, some of the other models have a slightly different eductor assembly, so this will vary a little bit, but the overall core basic here of how York is doing this will stay relatively similar. So this is a hot gas line coming in here, and then we have our eductor line coming right here. So there's a valve down here off the side of the evaporator. This particular one is a falling film style evaporator, so it's a little bit higher up, or I guess, no, it's a little bit lower down on the evaporator itself. Either way, so this is our eductor filter, and this is the solenoid valve that controls that eductor system. So when it needs to go into a recovery state on the oil side, it will energize this valve, open this assembly, and begin to allow the hot gas get pushing in through the eductor assembly to start siphoning that oil latent refrigerant off the top of the liquid level of the evaporator. Now, I do want to clarify and just put a reminder out there. This is where your liquid level control is really, really, really important for controlling the eductor feed. So the top few inches while your machine is running, which is when your eductor is going to work, because it doesn't work at a standby. So the top few inches of your refrigerant liquid level are going to be mixed with oil, because as the refrigerant stuff is boiling, the oil is going to get caught into the top of that, and it's going to get mixed in as your oil latent refrigerant right at the top of the liquid level section. And that is where you want your eductor to be pulling from. So if you're running too low of a liquid level on your evaporator, you'll start to push down, and you won't have as much success getting that oil latent liquid refrigerant to pull back into the eductor assembly. So that's something to be aware of. Be very careful of that, which could then lead to you've already got a low level in your evaporator, which is going to impact its operation and efficiency. But then you add it getting oil logged because you're not getting up to where that eductor port is, then you could start causing even more issues with oil logging. So whenever with a YK, you're going to set the liquid level set point based off the condenser level, but you have to pay attention to what that means on your evaporator side and where that evaporator is, or the liquid level is in the evaporator. And so these things have to have a bit of a balance. I've talked heavily in the past through other means about how we need to set the condenser levels on our YKs for a proper operation, but we cannot ignore where the evaporator level is in that process. These two go hand in hand. That also means that when we have a high liquid level in the evaporator, we have high potential of pulling back a lot of basically just pure liquid refrigerant. It's not even oil latent. And what that can cause, especially in this particular style of a sump assembly, is the very top of the sump, when we run really high liquid levels, can start to frost and freeze up here. You'll actually see a frost film begin to form. And this is for this particular style because the eductor block in this style is right here, and there's some the ports push in right here at the top of the eductor or of the sump itself. So basically what's happening is if the liquid level is too high and we're drawing in just mostly pure refrigerant and it's not actually oil latent to dilute it down, then one, your oil is still going to be stacking in the evaporator because, well, you're your eductor intake port is lower than the oil level itself that is in the evaporator, but then you're going to be sending straight liquid refrigerant from the evaporator into your sump assembly, and that's where it gets injected and it hits the top of the sump here. It begins to form a little bit of an ice shield, or not shield, but there's going to be some ice formation, and it gets really cold. It may be sweating a whole lot right in here, where normally it wouldn't do that. Like this sump assembly shouldn't be sweating, and the rest of the tank won't be, but it will be just right in this region, and that is one of the symptoms of too high of a liquid level in the evaporator. Or if you're having an issue with your discharge port here not actually sending proper discharge gas, that could also cause an issue as well. But either way, that is what you need. That's something to look for, and we have to be very careful in where we're maintaining that liquid level in those machines, so that we, when we are using that solenoid valve to control the system or to control the eductor oil recovery system, that we're not undershooting or overshooting. And there is this little sweet spot, which York specifies that they want to see right about half glass. Like in a perfect world, their evaporator, when everything is balanced and tuned correctly, is going to run about half glass in that sight glass. So that you should be targeting about that region. And if you do see, say, if you start to see a oil film which will have this kind of yellowish tint to it in your evaporator, and the level is low especially, then you may want to consider maybe your level is too low on the evap. Now you could also have an eductor system issue. That solenoid could have an issue, that valve could have an issue. Somebody may have serviced the filter and forgot to open the valves. That could be an issue. The eductor filter itself could be clogging up. That could be so there's all kinds of things that could be causing your oil to stack in the evaporator naturally. But having a low level will definitely do that. So that's something to look for. At the same time, if you're seeing a high level where you're above the halfway point considerably in most cases, and you walk around to the sump and you see that it's condensating at minimum quite heavily there at the back end of it, well, then you've probably got too high of a level, and you need to evaluate why is it that high and what can we do to lower it. You may have an overcharge. It also may be just a poor set point on the condenser side. There was a time when, especially in these older machines, when the metering or the variable orifice valve was first getting implemented, when they were transitioning away from the orifice plates for the original YKs, that it was just common practice that, you know what, those metering valves, the PID for them just had too many issues. We're just going to remove that because it's just creating a problem, and they would manually open that valve, or they would adjust the set points to where the valve would basically just stay open all the time. What that would do, though, and many times it would cause, especially if you do that on a newer machine, which has significantly improved since the early versions, you'll see that evaporator level just run way too high. You'll run hardly anything on the condenser. It cause all kinds of problems there. So some things you can, and I still see on occasion, like even on some of my videos, people will still comment about just setting those variable orifice valves on the YKs to just basically be full flow all the time, and like that, I just don't agree with that practice. But either way, that is where your return solenoid is for the eductor system, and then some thoughts around making sure you're controlling that properly. All right, let's jump into go away. There we go. Jump into this question here. All right. My question is, what's your advice to a tech who's comfortable working on screws and desperately wants to get into centrifugals? So, and this is, I would say this is a fairly common place to be for many people, because in your progression in your career, most of us end up starting on air-cooled scrolls, and as you get comfortable with that and you get used to working on them, yeah, that eventually kind of scales into an air-cooled screw, and then you get kind of caught up in this whole air-cooled realm, and then sometimes you may start running into water-cooled screws, or maybe even water-cooled scrolls. They do exist out there, and then you get caught in this whole scroll and screw cycle, and because centrifugals are just they are another level of what we work on, and most people really struggle to understand like, and the, how about this, the cost of something going wrong because you did not do something correctly is very high and very easy in a lot of situations. It's not that hard for you to make a mistake that was a genuine naive choice that leads to a $100,000 overhaul. Really not that hard to do. So, for example, leaving a valve closed on the adductor assembly and allowing the evaporator to start stacking on the oil migration or the oil level stacking in the evaporator, that causing low heat exchange issues, which eventually could lead to liquid refrigerant droplets getting pulled into the evap or into the compressor, which will shred it, or you change a set point incorrectly. I mean, I could go down a list here, right? There's lots of things you could do wrong because you just genuinely didn't know any better. And that is why not only the facilities people that are running these plants, but also probably your management is really nervous, because that is a lot of liability for somebody who, in their eyes, they have not seen proven their centrifugal ability. And this is what you're going to have to work through overcoming. And so if you want to work on that equipment, and in the context of maybe you don't want to change jobs, okay, and you want this company you're working for does centrifugal work, they need more help on the centrifugal side, but them being willing to allow you to is becoming a hiccup. Well, you've got to show them that you're ready for that type of work. And the best way I could recommend doing that is show them that you know what not to do, and start just having some of these discussions. And even like if you're going through any of my training I do, whether it be YouTube or in the academy, whatever, I really talk through with them and open a dialogue of, hey, I really want to do this. Here's things I've learned. I've learned that when we're dealing with a surge situation, I can lower my current limit and help unload that machine to get out of a surging state. I understand that I need proper GPM, and I'm going to use my DPs. And if I know how to convert feet of head to PSI, and so by that I can take the submittal data if I have access to it and figure out what my flows are. You know, without getting off on a spiel here, you go through this process and show and explain in your words that you actually understand this stuff on a deep enough level, even if you haven't directly put your hands on to experience it. This is the whole foundations conversation. Really good foundations, and just having a basic core repository of what should and shouldn't be, even if you don't have the experience to back it up, will go a long way into helping you just approach a machine and then getting opportunities like this. So if you couldn't sit down in a conversation right now and give that breakdown and express to your manager, or if you're trying to convince somebody at a facility, let me help you, right? Obviously, different context, different conversations, but if you can't sit down and have that conversation and explain that, listen, if you're concerned about my training, this is what I know to do. This is what I have learned so far. And this is how all this works. If you can do that and show that foundation, then the risk you pose walking into that plant and breaking something is significantly reduced. You are far less of a liability to that customer and to that company. Way less of a liability. And that is, especially in today's job market, one of the big things that's going to keep you out of a lot of opportunities. Now, there are plenty of bad companies. There's plenty of companies that pick and choose. Hey, even if we've got more work than we can handle, only these guys are going to do it. You're going to go work on this over there, right? That kind of stuff happens. And I've been in the role of the manager. It's very difficult and it's very tricky who you can send, what, where, how, why. Like, that is not a simple process for them. You can help make it a simpler process. Now, and all this is in the context that your company even has centrifugals to work on or is willing to work on them. If you are at a company that isn't or doesn't do that type of work, you'll have to find one that does. Now, I highly recommend, if you want to put yourself in a much better position, before you try to go find a company that does, have a strong enough foundation to where you can have that conversation in the interview. Hey, I want to do centrifugal work. I've had limited opportunities getting into centrifugal work. Be upfront with that. Don't hide these things. But then express the education you've gone through to show why you deserve an opportunity to do centrifugal work, and that you know enough to know how to not break it. Like, that is the core thing. It's got less to do with what you can do, in my opinion, and a lot more to do with, do you know how to not break it? And can you be in there with the customer and properly speak with them and to them and move, like, you understand the fundamentals of the machine enough to actually accomplish something without having to break it first to know better, right? That is, in my assessment, one of the best ways you can either advance your position, or if you're going to move to a different company, like, have that when you go to make that move. And this is in the context of, like, you understand, you can show your screw chiller background and all the stuff. I think it's a bigger issue with just the mentality and the mindset of the people who are making the decisions on who gets to work on what. In their mind, especially if there's somebody who doesn't have proper experience, but they know that centrifugal, big, scary, right? Big, expensive. Like, that only makes your job a little bit harder because now you're trying to convince somebody who doesn't know, and their whole job is to just not create a liability. Like, liability and loss aversion. Loss aversion has so much to do with this process. In my experience, changing companies is actually one of the easiest ways to advance in the industry currently. Now, that's sad to say. I really don't want to promote having to company jump to make moves and advance yourself. I really don't like that. I'd really rather we do a better job as managers. And I'm guilty of this, okay? I have to convict myself in what I'm saying. Like, I've been in that position, and it is what it is. So, but in the end, in the decisions we have to make, many times that is the easiest choice. If that's what we're seeking, is the easiest option. So, yeah, that would be my approach to. I want to get into centrifugals. I'm really good at chillers in general because 80% of what you need to understand, you learned with screws and scrolls. Like, a lot of what you need to know, you learn there. Then you just plug in the centrifugal compressor aspect, and especially surge. Okay, plug in the surge and the centrifugal aspect of the equation, and you could argue low pressure, if you have accounts like that. So you just stack that extra 20%, if you will. I'm just throwing numbers out there on top of that 80 you've already got as field experience. And in my opinion, you can make a really compelling argument if you've put the work in to build the foundation. If you haven't, then I would say start there. That would be, if they're not already just giving you an opportunity, then without showing you are something makes you stand above the crowd and as to why you should get an opportunity, it's going to be a lot harder, right? You're going to have if in some cases they'll just be willing to hand it to you, but if they're not, you've got to show something more to convince them. And many times that will mean your actual education, yourself, and why you should be the guy. Yeah, that's my thoughts on that. Discharge check valve on both machines. One check valve disintegrated and bent the tube in the condenser. Oh yeah, yeah. Check valves on the Daikin Turbocors were a major issue for a long time. They seem like they've got a pretty good system going now, though. I like their newest iterations of that, but in the early days it was leaf. Right, you also need me. Yeah. If you're doing the test harness for the turbo core, yeah, make sure your meter and your leads are rated high enough, because you are dealing with high voltage DC at that point. So and it is over 600 volts. All right, we use 600 as kind of a baseline, but it's over 600 volts. So you need to be very, very careful and make sure you've got the correct equipment. I do not want to see anybody get hurt. Is that the poppet discharge? Yes, figured so. Just kind of skimming through the comments here, see if we got any questions. Freaks when they hear the discharge check clanking. Yeah. I mean, Jason, to be fair, it is a pretty disconcerting sound. If you don't know, right? Once you know what it is and those turbo cores fire up, like it's not so bad, but it's, I mean, you really, it's funny to see a customer who you put a brand new one in and you go to start it up for the first time and then they hear that and they're just, it's like, no, it's okay. It's going to do this. It's on purpose. It's part of the design. We have a way to fix it. I don't know if this is the right channel to ask. But do you have any tips for a young guy trying to get into BMS systems? Oh. Yeah, I mean, I could give some thoughts on getting into automation as a specialty. Am I the best person to ask? No. I've learned it. I'm quite familiar with it. I would say Distech, in terms of education, Distech and Honeywell both, I think. Both of those have really good education systems around that. MCS, micro control systems. MCS has some really good education. I love working with those guys. And those would be the two I would probably really want to dive into on your side of it. Look at their training resources they have from a training perspective. Most of the companies that do automation, what I've seen that they do is you go in as an installer and you spend quite a few years pulling wire, installing the systems, and as you work your way up the ranks, you can eventually start doing more of the programming side and learning the computer side and getting into more of the software. Now, I'm sure you could accelerate that process by doing a lot of your own education. But in terms of like what I personally have seen in just the general format of how that goes, like they spend a lot of years just pulling wire, plugging in controllers, and then eventually, learning the computer side. And as you scale through that, then you get to a point where you can start working on actual control systems and writing programs, doing maintenance stuff. Like that's been the process I have witnessed. But no, Justin, I'm not the best resource to ask that question. WMC likes colder water. Yeah. Having issues with both machines running together. They are riding surge line pretty bad. I think that they were undercharged on startup and I completed. Okay. Trying to lead lag them. Low load. And just kind of skimming through. mouse misplaced. Skimming through the comments here before we get to the next question. Almost had to force my way into barely starting to touch Turbocors. And we work on act like being near centrifugal. Yes. Those RTAs are Cattleman's. One of the best air-cooled chillers ever made. Yeah, RTAs are utterly fantastic. I mean, to this day, I absolutely love what Trane did with the RTAA. It was such an incredible machine. Congrats. Yeah, thank you, Matt. See mechanical environments here. I see them pretty far back in the chat. Way to go. We do experience tech shortages, but mostly regarding skills. There's a lot of techs doing HVAC, but not so much chillers, particularly techs that actually know what they're doing and are reliable. Okay, so you've got the same issue we have. We're getting to a point where we have people, but they don't have the training yet. That's what we're here to fix now. However, even then, companies still act like it's a privilege to be allowed to be around bigger tonnage units, especially centrifugals, although I understand not just anyone should be allowed. If a tech is decent and skilled, wise, and willing to learn, why not let them learn alongside another senior? Well, to respond to that specifically, I don't know about your situation, but I know that as a whole, most of the time we don't have the capacity to allow seniors and junior techs to properly work together at our current state. And new technicians have far more callbacks, are a lot slower on the job. They take a lot more time, and so it takes more of them to do the same amount of work most of the time. Like they just don't move as fast, and that's not a knock on junior techs. That's just the reality of your learning, and you're early in your process. You haven't figured out all your tools. You haven't figured out all your processes. Like there's a lot you haven't figured out yet. That's just going to come with time, and so that means that even though we may have, in terms of quantity, more people on the team, we're not able to get the same volume we had when most of the team were 10 plus years in the trade. When majority of the team is at that level, then you don't need as many people to do as much. Because as long as they're all, adequate workers, they've all worked through all of those entry-level processes, and they can just get in, get it done, move on, and it doesn't take as much. So as to why we don't get to spend more time, or companies don't allocate those guys to spend more time, and it does come down to they've got to cover the workload. It's been my personal experience with that. I have seen plenty of times that office politics plays a part in people gaining experience or not. Absolutely, Jason. You and I both know that office politics is difficult, very difficult. Yes, of course, but there are reluctant to allow you to learn some privileges you must somehow earn. Yeah. Do that anymore. I don't see a lot of carrier centrifugals in the field. Do you see a lot of them in your? I mean, we don't have too many carriers in my region that I personally see. I mean, they definitely exist. But York and Trane would be the two primary dominants, and then followed up by probably Daikin. I see a lot more Daikins than I see in McQuay, Daikin and McQuay, than I see of carrier at this point. But the carriers do exist. They do have a presence. They're not non-existent. There are not a ton of carriers in Centrifugal. Yeah. Again, biggest names. Yeah, shout out to all of anyways. Thank you, Jason. I see your words there. I appreciate it, bud. Fantastic. Much needed. Seems like an awesome. Yeah, in terms of Daikin local to us, if in terms of Central Texas, Daikin is definitely they're a good shop. I really like. I like what I see them doing. I like the team that I see they've put together. So if you're in the Central Texas region, Daikin is somebody like you want to work for an OEM. That's one I would have no problem saying, hey, go join with these guys personally. I don't know about other regions. That changes heavily, but where I'm at, feel the pain of guys that are having trouble breaking in. Yeah. All right, so I'm gonna skim through a little bit here, trying to see if I just want to see if we have any questions. Let me fit everything. Can you go further into the Daikin Turbocor check valve issues? I have a building with 2 that make racket. Okay. Brad, let's do it. Yeah, it looks like we may still have Jason in the chat. Let's see, maybe catch up. Is there a service bulletin? Chattering, discharge, how to be up and running. That's when we use, which not all machines had the part load balance valve. It depends on how old his machines are. There are service bulletins about check valve, especially the poppet. Is it solid? Yeah. Okay, PRV has been running. Buildings, economizer control. Made all the recommendations. Cheap property management. Yeah. Yeah, let's I'll take a minute to talk about this myself. I see Jason as which Jason's with Daikin, if you don't know. He can very much talk to these things directly. I may even have, I think I have some pictures. We can do some show and tell on this a little bit. Let me get the pictures loaded up so we can actually talk about, oop, oh, go away. Give me just a second here. Let's use this one here. I should have a good shot of the P. Jason, you'll recognize these photos, by the way. So I don't see the part load on this one, though. Oops. Let me see. Just doing a quick grab here without killing a whole bunch of time on it. Can we see it in this one? That's our cooling. That's our liquid line. Okay. I do have pictures somewhere where we can see it, but these pictures I'm not seeing it. I'm actually thinking this one. Okay, well, let's just dive into this. Can you go further into the Daikin Turbocor check valve issues? I have a building with 2 that make a racket. So one of the things that Turbocors do, and they're not the only ones, but there's a check valve in the discharge line. And we can come over here and look at this. So the check valve is right down here. And Daikin has gone through a number of iterations on this process. So here's your Turbocor discharge coming over. And they've put them in a few different locations. The tonnage of your machine has a part to play in this factor. But the very early versions of the machines had the particular style that they were using had really bad trouble with braking. And it would, in some cases, because they had like they had a swing style at one point. They also had where it's basically split in half, and there's a core shaft and it opens up on either side. And then the one they're using now is basically the whole center pushes back on a spring, opens up the check, and once it builds up enough force. So part of what is the point here is, as the centrifugal is spinning up, this check valve is there to help prevent a major backrush whenever we go to shut down. If memory serves, that's why they're implementing it, to prevent the condenser pressure at coast down and shut down, causing a major backrush into the compressor, which causes issues. And this compressor also needs a second because it spins up very slowly, so it helps it generate some lift, if you will, for the startup cycle until it gets up to speed. And once it's there, it's fine, and the check valve can open. Everything runs just fine from there. Jason, I do see your comment. At the moment, it would take a second for me to boot one up, but I can throw that picture into the later video of this. So either way, yeah. So once we're spinning and we're at speed, then this check valve just stays open from there. And a huge part of what happens, though, is during the startup cycle, as the compressor is starting to build some pressure on the discharge, it'll build enough pressure to momentarily open the check without actually being able to sustain it. So basically, the check will open some as a relief. It will relieve the pressure that had built up, and it's going to slam shut. Now, this happens very rapidly, and it's where you'll hear this clank, 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 and it kind of just smooths out as the compressor is able to get up to speed. That hammering that you're hearing was causing a lot of valve failures in the first and early generations. So that led Daikin to do a couple of things. One, they improved the design or the iteration of the check valve itself. The design they're using now, they've been using for a number of years, and it's actually gone really, really well. So they've got a pretty good design at this point. The other thing they're doing is they implemented a part load balance valve assembly, which is the PLBV. So what that does is it actually, I don't have a good depiction of it at the moment. It actually has a line that connects to the discharge up here and then runs over to the condenser. And what it's doing is it's a metering valve that opens up and allows some gas to bypass the check valve. And what that does, it doesn't eliminate the check valve from hammering or chattering, but it does reduce it significantly. So it takes a lot of that mechanical stress that was put on the check valve out of it, and allows some of that gas to flow around without it being too much, right? So this whole process, it doesn't have too much of the pressure being relieved off of here, because we still need lift to be created to get the compressor spun up properly. So once we get up to speed, then we can close the part load valve, and the check valve will go into a full open state, and everything just runs normally from there. Like, that's just a real high level of what is happening with that process. Now, Daikin made retrofit kits that you could put into older machines, and you would basically just have to you would have to put in a tap on the heat exchanger and the pipe. You could install the valve assembly, and you could also upgrade the discharge valve that was in there at the time. And you could do this whole upgrade kit to prevent the failures, because a couple of things were happening with the failures. Either they were completely shattering and then sending shrapnel into the condenser. That was one failure that was happening. Another failure was, especially when they had the gate style, is that gate would actually snap at the hinge, and then it would just block the whole discharge line. And so you'd go to try to spin up, and it would the discharge couldn't open because it was actually it had blocked itself off, because it had snapped off inside of there off of the armature. So that was one of the failures that was happening. Either shrapnel sent to the condenser, or it just completely stopped flowing discharge gas altogether. So like I said, as they've made several iterations to this, it's still going to be a factor on machines, right? So even with the most newest version of this, there's still a little bit of hammer, but again, it's compared to what it was originally. It's not that much, and Daikin has engineered things in a way to where it can handle that just fine. It's no longer an issue. So if you have an older machine, you may consider implementing some of these processes to help, either doing a retrofit for the part load valve if you don't already have it. You probably want to upgrade the discharge check valve as well to the newer style, so that you don't risk like having a complete shutdown, because the original styles, if they've even lived this long, which if they have, if you do have one of those older ones, congratulations. Like most everybody else's didn't make it that long. So yeah, so that would be my that would be my suggestion at that point. Is one, that's what is happening, but then two, that was Daikin's way of trying to correct that. Now, any way to determine the type of check valve externally? Let me think. If I'm not mistaken, I think they should have a, like a, was it a body number? I don't want to call it a part number, but they've got molded numbers or stamped numbers into the body of the valve, and you will probably have to take that number. I don't know that level of specifics, but you could reach out to the local Daikin shop and be like, hey, this is the valve I see in there, and you may be able to get it identified that way. Other than that, I don't personally know of any other way to identify which style you have. More than likely, if it looks like because the factory valves are going to be painted the color of the machine. And so if it's been replaced, they typically are like a blue color. So if the valve is different color than the discharge line, which they use that beige kind of tan type color, then if it is that color, it's probably original. And if it's an older machine and it doesn't have part load balancing, then you probably have one of those older valves just by that metric alone. And it would be worth evaluating whether or not you should do the upgrade. And then, like I said, they have actual kits they put together to do the valve installation on older machines whenever you needed to do that. So you have two different ports to use, one above the check valve and one on the barrel, if you want to see it on a gauge. Any way to determine the type of... Oh, you're talking about the pressure. Okay, I see. Yeah, it gets really hot in my office when I stream, especially for extended periods of time. I don't have proper AC in here. Go figure. Being an AC guy, I should do that. Let's see. Yeah, so that would be my suggestions, recommendations there, right? You're at some point in this process, you're probably just gonna have to get Daikin involved and get their input on, this is what you have, this is the kit that you're gonna need to help correct this, because they have had to address it. Like, this was a major issue for them for a lot of years when they were first getting these machines out into the market. Yes, and Jason made a comment too. You will need to update the software with installing that valve, because obviously that wasn't a part of the original software and the scope when they first built them. So if you do have to do the upgrade package, you will need to update the firmware, which on the Pico 2 series it's not that complicated, but it's not the most straightforward thing in the world either. It could be more intuitive in my opinion, but they're still using the Pico 2 controllers in those systems. So anyway, okay, all right, let's see, let's do, how about this, are you still on the coffee holding, or is your body still saying no? Let's follow up on that. So for those who don't know in the context, A couple of years ago now, it's crazy to think it's been that long. So I had a day where I had two big cold brew coffees. It was a hot day. I ended up getting caught up in a centrifugal plant for the majority of an afternoon. I didn't have access to proper water, yada, yada, yada. And so um, I ended up getting severely dehydrated at that plant. Now, if you haven't experienced this, severe dehydration and heat exhaustion will sneak up on you and then hit suddenly. Well, that same day, I had a crew. I was a manager at this point, so I had a crew that was starting a tower change out, and they were going to do an over weekend change out, and they were starting into the day that Friday. So when I finished troubleshooting that plant, I then had to leave straight from there and go check in with them to make sure they had everything, so that if they needed any extra supplies, whatever they needed, I just wanted to make sure that that crew and the team leads that were overseeing that install were had what they needed. Well, I had just enough in the tank, my tank, to make it from that first site to the second site. By this time, I'd been so busy throughout my day. The two coffees I had in the morning had been all I had. Didn't even register to me that I had not drank anything else. Got to the site, checked in, got a material list of stuff they realized they still needed. Nobody had because the crane was already on site by that point, so they didn't have time to go pick the stuff up, and everybody was about to close for the weekend. So I got a material list, and I had just enough in me to get to the supply house. I started feeling funny by the time I was walking in the door. By the time I was leaving the supply house, I knew something was wrong. And I had gotten a couple of bottles of water, and I was trying to drink them, but it was already too late. It was just making me feel sick trying to drink the water in the first place. So by the time I made it from the supply house to the site, I barely got into the parking lot. Got parked, and I just had to call the crew on the roof, one of the leads, and be like, hey, something's not okay. Can y'all help come down? Because normally I would grab the stuff and start carrying it up and start helping them with that, but I knew I couldn't. It was too late. So they came down, and by that point I just had the door open. I was just in the truck, and it wasn't good. So long story short, I ended up having a heat stroke and was severely dehydrated. I had to be taken home. I didn't want to go to the ER at the time. I'm just stubborn, as we all are. So I did end up the next morning. I had no choice. I couldn't eat. I couldn't drink. I had chills and shakes. I was in bad shape. I was really bad shape, and I got some IVs. I ended up having to take 2,000 mils of IV at the ER that next morning. Started feeling better at that point, and a symptom of that whole process, for several months I couldn't touch coffee. If I tried, it would make me feel sick, and I'd get a couple of sips in, if I even got that far, and I had to throw it out. So I had to give up on coffee, and I think I went to tea for quite a while. So that lasted several months, Sterling. That was like 4, 5, 6 months. And by that time, I actually started to slowly be able to get back into coffee. At this point, coffee addiction is going strong, sadly. So I am back in the swing of coffee. My body has gotten over that trauma, I guess you would call it. But yeah, I will say that I'm far more cautious, and if I know, yeah, I'm far more cautious. I drink a lot more water than I used to. Like I do a lot more than I like. That whole experience was a huge wake up call for me, and I'm not near as reckless as I used to be, by any means. But I appreciate you checking in on that, Sterling. It was a terrifying experience. So yeah, hydrate, drink water, be careful. Coffee is fun, it's good, in moderation. Make sure you've got water, make sure you're drinking water, make sure you're taking breaks, make sure you're doing all the things. I don't speak this because it's what I'm supposed to say. I say this because I've walked that road, I've lived that life, I've made those mistakes, I've paid my price, and I would rather you not. I'd really, really, really rather you not. And I mean, even from a manager's perspective, it's a tough position to put the rest of your team in, because now instead of just doing their thing and having a fun time on the job, now you've got somebody down, manager or not, you've got somebody down, and it's a very difficult situation on site, and it really, that's not where everybody's head should have to be. So I see it now as like, don't do that to your coworker. Like, if you're not willing to take care of yourself, don't put your coworkers through that experience. How about that? Do it for them if you're not going to do it for you. So like, now their entire weekend was consumed with, was I okay? I'd rather them have gotten to enjoy the tower install and that whole process and really focused on that, rather than, am I okay? So yeah. Anyway, we're going to call it there. I really appreciate everybody's time. If you're not already in the academy, really love to work with you over there. We got an awesome community at this point. I'm trying to build as many resources as I can. And yeah, go check it out, chilleracademy.com. With that, MTT, make the time for your family, for your spouse, for your kids. There's not going to be time. You have to make that time. We're going into busy season. These are things that it's worth taking time to consider and think about, and just do. All right? Just do. Your family needs you. If it's not for them, why are we doing what we're doing? Just what's the point? Anyway, I appreciate it.